Hey guys, in this lesson we would understand what are the rules of derivatives. These are going to help us find the slope of a given function. The function could be any kind of function. It could be exponential, trigonometric, polynomial, rational function. We will first begin with understanding the rules of derivatives for polynomial functions, and slowly we'll move on to different types of functions. There are two derivative notations. We can use either of those two. I will be using the function notation, that is the prime notation, because it's easier and then simple to write. The first example, we're going to write it down in both the notations, and then following examples, we will be discussing the derivative rules with the help of prime notations. The first rule of derivatives is, if our original function is equal to k here is any constant, then the derivative of this function is going to be equal to 0. In order to represent the derivative, we can use prime notation, that is called the function notation, or we can also rewrite it as d of fx by dx. We know fx is just another representation of the dependent variable y. Then we can also rewrite it as dy by dx. From here onwards, we will be writing all the derivatives using this kind of notation, which is the function or the prime notation. Let's first take up the example of this kind of a problem. If you're given function fx is equal to 3, then its derivative is 0. So for any constant value, the derivative function is always a 0. We all know derivatives mean slopes. So if the original function is a constant, then the derivative of that constant function is equal to 0. The second rule says if the original function is equal to x, then the derivative is equal to 1. This rule is an example by itself. If we now introduce any constant to this x, then we can have a third rule, that is when fx is equal to k times x, then the derivative of fx is equal to kx will be equal to k. Example for this is, if fx is equal to 3x, the derivative function will be written as 3. The next rule says, if fx is equal to x to the power n could be any number, here we can put n as any real number in fact, then the derivative function will be written as n times x to the power n minus 1. In order to avoid any confusion between the times sign and x, we'll just use times with the dot. Example for this is, if fx is equal to x to the power of 3, the derivative is going to be equal to 3 times x to the power 3 minus 1, which is 3 times x to the power of 2. We can add up another rule here, because not always x is going to be without a coefficient. So if we have fx is equal to k times x to the power of n, then its derivative is going to be equal to k times n times x to the power n minus 1. So in this case, you can multiply k and n together. Let's understand this with an example. So if we have fx is equal to 2x to the power of 3, the derivative can be written as 2 times 3 times x to the power 3 minus 1. That would give us derivative function equal to 6x to the power of 2. The next rule is called the sum and the difference rule. That is, if fx is written as the sum of two different functions, then the derivative can be written as sum of the individual derivatives of px and qx. Let's understand this with an example. So let's say if we have fx is equal to 3x squared plus 2x cubed, then the derivative can be written as the derivative of the px function, that is 3x squared, and the derivative of the qx function, that is 2x cubed. We don't leave it here, we need to solve it further, and we would apply here rule number 5, and that was this thing here. So we would rewrite it as k times n times x to the power n minus 1, and it would look like 3 times 2 times x to the power 2 minus 1. That's for the first function. For the second one, it's 2 times 3 times x to the power 3 minus 1, and we would get 6x to the power of 1 plus 6x to the power of 2. So the final answer is 6x squared plus 6x. We can write down the answer as the correct polynomial form. The same rule applies when it comes to the difference of two polynomials. So derivative will be written as p prime x minus q prime x. If we take up an example, where fx is equal to 4x minus 3x squared, then the derivative can be written as 4x prime minus 3x squared prime. Because it's 4x to the power of 1, it will look like a linear derivative, so the answer is just 4. But if we want to show our work using the fifth rule, because the power is 1, we're going to write it as 4 times 1 times x to the power 1 minus 1. This gives us 3 times 2 times x to the power 2 minus 1. When we simplify this further, we get 4 times x to the power 0 minus 6x. Anything raised to the power 0 is 1, so we are just left with a 4 here, minus 6x. If we rewrite this answer in the correct polynomial form, it would look like minus 6x plus 4. The next rule is called the product rule. In this case, we have fx equal to the product of two polynomials, and the rule says that when we have to find the derivative of this fx, we would first have to do the derivative of the first function, multiply it with the second function, then add it to the derivative of the second function, and multiply it with the first function. And when we simplify this, we would get our solution for the derivative of the product of two functions. Let's understand this with an example. Let's say if we have fx is equal to 3x minus 3 times 2x squared plus 5. So polynomial need not be only one term, it could be multiple terms. So here we are taking up an example using binomial for each polynomial px and qx. The derivative for this can be written as 3x minus 3 derivative, that is your px, times 2x squared plus 5, that is the qx. We add it to the derivative of the second function, that is qx, times the original function px, written as is. Now when we simplify this further, because this whole bracket has a prime sign, so this is going to be the derivative rules involving the difference of two terms. That means we will be finding the derivative of the first term as well as the second term. So how would it look like is 3x prime minus 3 prime. This whole thingy will go in a bracket times the qx function will be written as is, plus here the derivative of the qx function will involve the derivatives of the individual terms times 3x minus 3. So if we need to find the derivative of this, it would be 3 minus, this is a constant, that's a 0. This one would be 2x squared plus 5. This one would be 2 times 2, x to the power 2 minus 1, plus the derivative of a constant is a 0, times 3x minus 3. This would give us 3 times 2x squared plus 5, and this one would give us 4x plus 0 is 4x itself. In the bracket we have 3x minus 3. So now we can expand it. This one gives us 6x squared plus 15, and this one would give us plus 12x squared minus 12x. We can always collect the like terms, so 6x squared and 12x squared will be collected together. That would give us 18x squared, and then we have a minus 12x written behind it, and then finally we are left with a plus 15. So this is the equation of our derivative function when the original function is given to us like this.